Hello students, this is a video on the quant topic tests available on the Bodhee Prep Android app. Now, the basic idea of these tests is once you go through a concept, you want to check whether that concept is exam ready or not. You take these tests so that you know whether you're able to apply the concepts in the exam. With every test, there is a video. The video will give you the solutions and an overall analysis of what would be a good attempt. There are more than 200 such topic tests available on the Bodhee Prep Android app, the link for which is in the description below. Make sure to download the app and make the most of these tests. This test specifically is on, or this video is on solid geometry, 3D mensuration, test number 2. Overall, the test is about moderate. 6 to 7 questions in about 22 minutes would give you 6 to 7 net correct, would give you a 95 plus percentile. If we look at the questions that are there, the first question says the curved surface area of a solid cone. Curved surface area of a solid cone is 3/5 of the total surface area of the cone. Now, curved surface area of a cone is nothing but pi RL, and the total surface area is pi R into L plus R. This is 3/5 of this. Pi R cancel. So 5L is equal to 3L plus 3R. 2L is equal to 3R. 2L is equal to 3R. Therefore, we get the ratio between L and R as 3/2. 3/5 of the total surface area. This is one relationship that we have. L by 3/2. 6. This will be 5 and 3. 5 and 2, 6. Okay. Find the volume of the curved surface. Okay, the curved surface area is given as pi RL is given as. So let L be 3x, R be 2x. Curved surface area pi RL is given by 924 by 5 centimeter square. So 22 by 7 pi. R is 2x into 3x is equal to 924 by 5. And therefore x square will be 924 by 5 into 7 upon 22 into 2 into 3. This will be the value of x square. 924, 13 minus 11. 924 will be divisible by 22. This will come out to 4s are 88, 42. 2 3s are 6, 6 7s are 40. So x square comes out to 49 by 5, which means x is nothing but 7 upon root 5. We have to find out the volume. Volume is 1/3 pi r square h. R is okay, h is not there. So from here we can say r square plus h square for a cone is equal to slant height. So 4x square plus h square is equal to 9x square, which means h square is equal to 5x square. H square is equal to 5x square. 5 into x square was 49 by 5. So h is nothing but, or h square is nothing but 49. So h comes out to 7. Now we have the values. 1/3 pi r square h will be 1 by 3 into pi. R will be 4x square. Pi we can write 22 by 7 into 4x square. So 4 into x square. X square is 49 by 5 into h, which is coming out to 7. 7 and 7 cancel. Nothing else gets cancelled. So we'll have 88 into 49 by 15. 88 into 49 by 15. 88 into 49 will be 50 into 88. 440. 440. Not 440. 50 will be 4400. 50 minus 1. This will come out to 4312 upon 15. 4312 you have to divide by 15. So 15 twos are 30. 30. 131. 8s are 120. 111. 7s are 105. 2s are 30. 131. 8s are 120. 112. 112. 112 minus 157. 287, 7 by 50. This is a different calculation. So these are the set of calculations that need to be done. So first we find out the relationship between L and R, step 1. Equate this to the given curved surface area to get the value of x from the ratio for L and R. Substitute it in R square, H square, L square to get the value of H. We now have the values of R and H to get the volume, which comes out to 287. 7 by 15 becomes my answer. In terms of level of difficulty, maybe a moderate question, but the solving time will be high because there are multiple steps involved. Easily 3 minutes to solve. P and Q are two solid spheres. If the volume of P is a% less than that of Q, while the surface area of Q exceeds surface area of P by 300%. P, Q, surface area 300%, they are spheres. And therefore we can say, if the surface area of P, suppose, will be 4 pi r square, this will be 4 pi r square into 1 plus 300 upon 100, 300% more. So this is nothing but 4 times of 4 pi r square. Why will this happen? This will happen because the radius is 2 times. So basically this is 4 pi 2r whole square. So the radius of Q is twice of radius of P. Therefore the volume becomes 4 times, which is 300%. The surface area becomes 4 times, which is 300% more. What about the volume? Now the volume of P will be 4 by 3 pi r cube. The volume of Q will be 4 by 3 pi 2r cube, which will be 8 times of 4 by 3 pi r cube. If we assume that the volume of Q is 8, the volume of P will be 1. It says P is a% less than Q. P is a% less than Q. So P is 7 less than Q, which is 7 by 8 into 100. Q is 8, P is 1. How much percent less? 8 going to 1 means a decrease of 7 on a base of 8. 7 by 8 will come out to 87.5%. This is the value that we remember. Option B becomes my answer. Again, if we understand percentages, should not take more than a minute and a half to solve. The height of a cylindrical cylinder reservoir is 50%. 50% more than the radius of the base. If base is 2, height will be 3 and so on. The circumference of the base of the reservoir is 880. Circumference of the base will be 2 into pi into r. This is given as 880. 2, 44, 20. The radius becomes 140. 140 centimeter becomes the radius. Since radius is 140, height will be 50% more. 50% of 140 or half of 140 is 70. So height will be 140 plus 70, which is 210. How much will it cost to fill the reservoir completely with water if the rate is 0.3 per liter? So the volume of the reservoir will be pi r square into h, this cubic centimeter. If we solve this, we'll get 22 into 2 into 14 into 21, 000. 22 into 2 is 44. 44 into 2 will be 88. 88 into 7, 616. So, this becomes 6160. 6160 into 2 will be 88. 88 into 7 will be 616. 616 into 2 will be 88. 88 into 7 will be 616. 616 into 2 will be 88. 88 into 7 will be 616. 616 into 2 will be 88. 88 into 7 will be 616. 616 into 2 will be 88. 88 into 7 will be 616. 616 into 2 will be 88. 88 into 7 will be 616. 616 into 2 will be 88. 88 into 7 will be 616. 616 into 2 will be 88. 88 into 7 will be 616. 616 into 2 will be 88. 88 into 7 will be 616. 616 into 2 will be 88. 88 into 7 will be 616. 616 into 2 will be 88. 88 into 7 will be 616. 616 into 2 will be 88. 88 into 7 will be 616. 616 into 2 will be 88. 88 into 7 will be 616. 616 into 2 will be 88. 88 into 7 will be 616. 616 into 2 will be into 210. Further, this will become 616 into 21. 616, 1232. 1, 2, 3, 1, 3, 12936. The 12936,000 cubic centimeter. In terms of liters, we can divide by 1000. So this becomes 12936 liters is the volume of the reservoir. This is being filled at rupees 3.3 per liter, and therefore total cost will be volume, which is 12936 into price, which is 0.3. Multiply 6 is 18, 8, 1, 9, 10, 0, 1, 28, 2, 6, 8, 388, 0.8 rupees becomes the answer to this question. Option A. Level of difficulty may be conceptually easy, not a very difficult question, but there is calculation involved. So, about moderate question, 2 to 2.5 minutes to solve. The volume of a sphere Y is 26% higher than that of sphere X. Volume of X, volume of Y, 26% higher. 2600% higher. So, if the volume of X is 1, we can say the volume of Y will be 1 into 1 plus 2600 upon 100, which is 27 times. So, if this is 1, this is 27 volume. We know that volume is proportional to the cube of radius for a sphere. So if the radius here is r, the radius here has to be cube root of 27, which is 3r. So here the volume is 4 by 3 pi r cube, which is equal to 1. Here the volume will be 4 by 3 pi 3r cube, which will come out to 27 into 4 by 3 pi r cube, which is 1. And therefore 27 will be the volume. So basically the radius is in the ratio 1:3. Surface area of X is p% lower than that of Y. Surface area of Y, surface area of X. Surface area of Y will be 4 pi r square, which is 9 into 4 pi r square. Surface area of X will be 4 pi r square. If 4 pi r square again is equal to 1, for our calculation, we can say the surface area of Y will be 9, the surface area of X will be 1. It says what is the value of P? X is p% lower than Y. 1 is how much percent lower than 9? 1 is 8 lower than 9. We are comparing with 9, so 8 by 9 becomes my answer. 1 by 9 is 11.11, so 8 by 9 will be 8 into 11.11, the value that we remember, or 88.89% becomes the answer, option D. Again, if we know percentages, should not take more than a minute and a half to solve. Two right circular cones whose heights are different have the same slant height. The product of their base radii is equal to the product of their heights. Okay. Two right circular cones. Suppose the height here is h1. The second one has a different height. Suppose the height here is h2. But the slant height is same, so both cases L. The product of their base radii is equal to the product of their heights. If the base radius of the height of the cones are 5 and 6 of one of the cones, base radius is 5, height is 6 of one of the cones, find the sum of volumes of the two cones. Now it is given that the product of the base radius, so 5 into R2 is equal to 6 into H1, 6 into H2. The product of base radius is equal to product of heights. Also, the slant height is same. So I can say H1 square plus R1 square, if the radius here is R1, is equal to L square. This should be the same for, so here 6 square plus 5 square is equal to L square. This should be the same for H2 as well, because the slant height is same. So h2 square plus r2 square should also be equal to 6 square plus 5 square. Clearly, what we can do is if we interchange the value of h2 and r2, we get h as 5, r as 6. For the second cone, the product will be same 30 and 30 and slant height will also be same. We have to find the sum of the volumes. The sum of the volume for the first one therefore will be 1 by 3 pi r square h. The other will be 1 by 3 pi r here is 6 square into 5. So this becomes 25 into 6. Or we can pi into 25 is 150 by 3 plus 36. Pi into 180 by 3. This is 50. This is 60 and therefore 110 pi becomes my answer. Again, not a very difficult question to solve. Just understanding that cross values will give us the answer should be good enough. From there on, about 2 minutes to solve. A right circular cylindrical can of base radius 24, height 100 centimeters used to carry sand to a construction site. How many such cans will be required to completely fill a circular field of radius 20 meters with 18-meter thick layer? Again, this circular field, which is 18-meter thick, will also be a kind of a cylinder with base radius 20 and height 20 meters and height 18 centimeters. This is the volume that needs to be filled, which is carried from here. Suppose n number of cans is required, we can say that the volume of n cans should be equal to the volume of the field that needs to be filled. So for the cans, we can say number of cans is n. The volume will be pi r square, which is 24 centimeter into height, which is 100. This should be equal to the area of the field that is to be filled, which is pi. 20 meters, we first converted to centimeters, kilo, hecto, deca, meter, deci, centi. So 1 meter is 100 centimeters. So this becomes 20 meters is equal to 20 into 100, 2000 centimeters. Meter, deci, centi. 2000 r square into 18. And therefore n will simply be 2000 into 2000 into 18 upon 24 into 24 into 100. So here what we do is we cancel 0, 0. 3, 6 are 18, 3 8 are 24. 8 3 are 24, 3 2 are 6, 2 4 are 8, 4 5 are 20. 2000, 4, 1000 by 4 is 250. 250 into 5 is 1250. So the number of cans required is 1250. Basic calculation, it says number of cans into volume of cans should be equal to the volume that needs to be filled. In concept, easy question. Calculation also should not take more than about 2 minutes. The radii as well as the volumes of a right circular cone and cylinder are equal. So let the radius of both of them be r. The volume of the right circular cone will be 1 by 3 pi r square h of the cone. Suppose we say the height here is h1 and height of the cylinder is h2. So this will be h1. Obviously the height has to be different, only then the volume will be same. Cylinder is pi r square h2. Pi r square cancels. So h1, height of the cone has to be 3 times the height of the cylinder. Only then will the radius and volume be same. If radius of the cone is 3/5 of its slant height, what is the ratio of the radius to the height of the cylinder? Radius of the cone is 3/5 of its slant height. Suppose if we say that the slant height is 5, that means the radius is 3, which means h1 here height will be h1 square plus 3 square is equal to 5 square, because height, radius and slant height of a cone form a right angle triangle. So h1 square is equal to 25 by 9. 25 minus 9. which is 60. So H1 comes out to 4. If H1 is 4, H2 will be 4 by 3. What is the ratio of the radius to the height of the cylinder? Radius is 3. Radius will be same as this one, which is 3. Height of the cylinder is 4 by 3, and therefore the required ratio will be 3 into 3. 9 by 4 becomes our answer, option D. Moderate question, the reading is important. Solving time should not be more than about 1.5 to 2 minutes. Cylindrical pipe of length 75 meters cylindrical, through which water flows at the rate of 54 kilometers per hour, can fill 80% of a cuboidal tank, cuboid, of 118,800 meter cube in 14 hours. What is the radius of the cross section of the pipe? Now in 14 hours, the water that will flow through the pipe will be cross section, which is pi r square, into a height. Now the length will be, because water is flowing at the rate of 54 kilometers per hour in 14 hours, 54 into 14 kilometers worth of water will flow. Kilometers can be converted into meters, multiply by 1000. So this becomes the amount of water that flows in 14 hours. Cross section into the length of water, which is 54 into 14, because speed is 54 kilometers per hour in 14 hours. 54 into 14 kilometers worth of water will flow. Converting kilometers to meter, multiply by 1000. This is good enough to fill 80% of a cuboidal tank. So this should be nothing but 80% of 118,800. What is the radius of the cross section? So if we expand this, we can say 22 by 7 into r square into 54 into 14 into 1000 is equal to 80% of 118,800. 7 2s are 14, goes away directly. 0 goes away from here. This 0 also cancelled. And therefore r square comes out to 1188 into 8 upon 1188 into 8 upon 22, 54, 2 and 100. Uh, 1188 will be divisible by 22 because both of them are divisible by 11, both are even. This will come out to 5s are 110, 8 4s are 88, 54 cancel. This becomes 4, and therefore r square is 4 by 100, which means r will be 2 by 10. But this is in meters. Convert this into centimeters since we have to find the answer in centimeters. So we multiply by 100 to get the answer in centimeters, which comes out to 20 centimeters, or option A. Again, conceptually not a very difficult question, but there were conversions involved, and therefore I'm saying moderate, about 2.5 minutes to solve. In a solid cylinder, if the ratio of radius to the height is 2:3, find the ratio of curved surface area to the cylinder to the total surface of the cylinder. So let radius be 2x, height be 3x. Therefore, curved surface area of the cylinder will be 2 pi RH, 2 pi r into h. Total surface area will be 2 into pi into r into h plus r. This becomes 2 into pi into 2x into 3x upon 2 into pi r. 2x into h plus r will be 5x. 2 pi cancel, x cancel, we get 2 and 2 cancel, we get the value as 3 by 5. 2 pi 2x cancel, 3 by 2. So basically, the ratio is nothing but h upon h plus r, which is 3 upon 3 plus 2, 5, option D. Barely a minute and a half to solve. Easy question, just put in the formula, get the answer. The surface area of a solid hemisphere is thrice the curved surface area of a cylinder. Surface area of a solid hemisphere will be 3 pi r cube. This is thrice the curved surface area of a solid cylinder, which will be 2 pi r1 h1 or 2 pi r1 h. If the radius of the cylinder is 1/3 of that of the hemisphere, so here we can say the radius of the cylinder is nothing but r by 3, where r is the radius of the hemisphere. What is the radius? What is the ratio of the radius of solid hemisphere to the height? So basically, we have to find out the ratio of r and h. It is given that the surface area 2 pi r square cube. The surface area of the hemisphere total is 3 times the surface area, curved surface area of the cylinder 2 pi r h. Also, the radius is 1/3 of the cylinder. So if we of the hemisphere. So if we expand this, we get 3 pi r square. 3 and 3 cancel is equal to 2 pi r h. Pi and pi cancel, r square cancel. Therefore, r by h will come out to h goes to 2 by 3. What is the ratio of radius of solid hemisphere r to height of cylinder? R by h is 2 by 3 becomes my answer. I think relatively easy question, about a minute and a half or to solve. If we look at the overall test, therefore, about 22 minutes for about 6 to 7 questions. My choice of those 7 questions would be 2, 4, 6, 7, 9. 2, 4, 5, 6, 7, 9, 10. Which are these? This is calculation intensive, so not counting. Would have done this question every single time, percentage based. Again, calculation intensive, so maybe avoided. Percentage based, definitely doing this question. This also, I think, comparison question was there, and we did not need to calculate, just interchange the values, we got the answer. Therefore, doing this one as well. Here also equate the volume, get the value of n. This one also was a comparison question. I don't think difficult to solve, therefore would have done this question as well. Here, there were calculations involved, therefore I'm not considering this as one of the easier questions. This again was a comparison question, could have been done easily. Here also just equate the two formulas and get the ratio. So definitely doing this as well. Overall, 2, 4, 5, 6, 7, 9, 10 will give me my 6 to 7 net questions correct in about 22 minutes.